This is a strand beast. These wind-powered mechanical creations can walk, store energy, and even react to their environment.
These creatures are awesome and amazing in the way they operate, and that it's all through a mechanical system that you can see and observe and understand how it works.
If it was up to this NASA JPL engineer, these self-propelled creatures would be exploring one of the most mysterious planets in our solar system.
Venus is the exoplanet in our own backyard. The really important reason for going to Venus is to complete our picture of terrestrial planets with atmospheres in our own solar system, so that we know which planets in other star systems could potentially harbor life.
We just need to find a way to survive Venus's unforgiving environment, where lead melts and most electronics are destroyed before even touching the ground.
What that means is we have to completely rethink how a rover would operate and be designed to work. What I want is a strand beast on another planet.
Venus, often called Earth's evil twin, is a total mystery to us, despite having a similar size and composition to our planet. It was actually the first planet to be explored by a spacecraft. But after more than 50 years of studying Venus with probes and landers, it seems we've only barely scratched the surface.
I mean, we know basic information about the atmosphere, what's the makeup of it. We have very limited information. Part of that is because it's shrouded in clouds, which makes it very hard to observe the planetary surface. The other challenge is that there's just been a handful of spacecraft that have traveled to Venus.
After several attempts, the Soviet Union's Venera space program safely landed its first spacecraft on the planet in 1970. They sent more spacecraft over the next decade, with the longest surviving mission operating on the surface for just 127 minutes.
As you descend, both the pressure and the temperature builds until you get to nearly 100 times that of Earth's pressure and 465 degrees Celsius. That's hot enough where lead and solder would melt and paper would spontaneously combust.
These inhospitable conditions have made it easier to study planets much farther away, rather than the one right in our backyard.
We know quite a bit about Earth, and we're constantly learning more and more about Mars. Venus is extremely underexplored, and by understanding these three sets of planets, we can do what's known as comparative planetology to be able to help extrapolate what makes the conditions for life or against life to help answer one of those fundamental questions. Are we alone?
While the jury is still out on that one, both public and scientific interest are at a turning point for Venus. NASA recently approved 2 missions to study the planet's atmosphere and map its surface after not sending a dedicated spacecraft there in more than 30 years. But those missions aren't meant to survive on the surface. Jonathan believes that what we need is a presence on the ground.
We absolutely have to do surface investigations on Venus. And that's because, there's some questions that you just can't answer when you're farther away. Eventually, you need to get down to the surface and really look at things that you're not going to be able to see from a distance.
Remember, we're talking about hellish conditions here. NASA can't just send one of their Mars rovers to Venus.
For each planetary condition, you need to design a unique application for how you explore.
That's where the radically new rover comes in.
The hybrid Automaton rover Venus combines a little bit of steampunk with spacecraft to create a clockwork rover.
Jonathan's concept for Harvey went through NASA's Innovative Advanced Concepts program, which incubates ideas that have the potential to shake up space exploration.
We originally started off with a walking rover that looked a lot like Theo Jansson's strand beast, but after we talked with Theo, he advised us against the legs. That eventually moved us to a 4-wheeled rover concept using compliant wheels, and that would allow us to drive on the surface of Venus.
The original idea was an entirely mechanical creation, but after trial and error, the team found that tackling the most basic challenges like power, navigation, and data collection required a slightly different approach. The answer: a stripped-down hybrid system.
So the Harvey rover takes a very simplified approach to your standard Mars rover. Basically, we have the mechanical system, which does a lot of the driving, the operations, and the exploration of Venus. And then we have a subset of electronics that are designed for high temperature, made out of things like silicon carbide and gallium nitride. And these can actually operate at extremely high temperatures above that of the surface of Venus,
which will help this rover collect data like its Mars cousins do. But Harvey's hardware will be pared down in comparison. This means the rover will have to do much of the operations on its own, no humans at the wheel.
So the idea is an observe and report rover. It's likely that it would just be sort of a continuous transmission where you're just constantly saying, this is what I'm seeing, and cycling through different instruments.
But Jonathan and his team still have to solve a major problem. The high-temperature electronics have the computational ability of a solar-powered calculator, so they can only tackle basic processes. To traverse the Venus landscape, the team is looking to one of the planet's most abundant resources for a boost: wind.
So the wind seems to be the best approach for navigating the surface of Venus, with then a mechanical obstacle avoidance detection system that would sense obstacles in the near term, including holes, rocks, and cliffs, that the rover couldn't drive over and overcome.
If the conditions are right, Harvey could even withstand the harsh elements on Venus for up to 120 days, far surpassing the Soviet record of just over 2 hours.
Harvey handles the temperature by being built out of stainless steel and titanium alloys, which can operate at these extremely high temperatures and are impervious to the sulfuric acid content in the atmosphere.
Now, Harvey doesn't simply exist on the computer. Jonathan and his team have actually started putting the design to the test.
So what we have here is what we call a representative rover prototype. Now you'll notice it looks pretty different than the images of the CAD model, or anything you'd expect to see driving on Venus. What we're primarily demonstrating here is our mechanical drive system, the ability to detect an obstacle with our simple bumper here out the front, and the ability to reverse, back up, and then continue to drive forward after we've detected that obstacle.
The prototype does a fine job with rocks, but Jonathan's got a lean team to work with, so they crowdsourced ideas for a sensor to detect hills and holes. Then, they waited.
We were completely blown away by the response. We had architects, we had artists, as well as engineering students and tinkerers. I would have been thrilled with, 50 concepts even. But instead, we got over 500 concepts submitted. One of the incredible things about Harvey is that because it is mechanical and we're trying to look at how to do things in a simpler way, whenever I've talked to people about it, they connect with it in a different way and understand it and start even giving ideas of how to do different operations.
At the moment, the conceptual design for Harvey is about 95% complete. While Jonathan and his team are still working out the final details, he's already imagining what Harvey might uncover.
One is helping us understand the geologic variations across Venus. That can help give you a lot of information for why the planet is the way it is. Why is there a planet that's so similar to Earth in size, in location in the solar system, but so extremely different from Earth? How did Venus take this other backstory or change into this really hostile environment?
Of course, there's also the search for life beyond Earth.
We often hear the term life as we know it, but what about life as we don't know it? How could that exist and what would it look like?
Venus has been our underexplored sibling for so long, but that's all about to change.
Yeah, I should clarify that scientifically, Venus is not an exoplanet, right? An exoplanet is around another star. Basically, it's a planet that's very different from Earth, but similar enough that we might expect it to harbor life if we saw it around another star.